All right, let's look at graphing this system of linear equations. So let's start by graphing the first equation, 9x minus 2y minus 4. And let's do that by getting this in the slope-intercept form, y equals mx plus b. So we need to isolate y on one side of the equation. So we're going to do that by adding a 2y to both sides of the equation. And on the left we get 9x minus 4. On the right we have that equals 2y. Let's divide each term by 2. And now we have y isolated. Let's put that on the left side of the equation. And on the right side, which was our previous left side, we have 9 over 2x minus 2. So m is the number times x when we have slope-intercept form. So our slope, m, is 9 over 2. And that is telling me from one point to the next, move 9 units up and 2 units right. B is the y-coordinate of the y-intercept. So let's start by plotting our B. So that is the point on the y-axis where y is negative 2. A y-intercept lies on the y-axis. And from that point, we move 9 units up and 2 units right. The top number tells us how to move vertically. The bottom number tells us how to move horizontally. So let's use the graphing tool to put this in MyMathLab. We want to do the same thing. We select the line tool. We plot the y-intercept and click. And then from that we move 1, 2, 3, 4, 5, 6, 7, 8, 9 units up and 1, 2 units right, and we click. And make sure you're using the yellow box where it says click a line or point to it to see actually what the coordinates of the point are before you click. Now let's graph y equals 3x plus 1. This is already in slope-intercept form. Slope, which is m, is 3, which we write as 3 over 1. The constant is our b, which is the y-coordinate of our y-intercept. So we plot the y-intercept, and from there we're going to move 3 units up and 1 unit right. And that will give us our second point on our line. So from the y-intercept, move 3 units up, since that top number is positive, and 1 unit right, since the denominator of the slope is also positive. Okay, so we're going to use the MyMathLab line tool to graph that. Plot the y-intercept, move 3 units up, 1 unit right, and we click. It looks like it's right at this point, which if we look at the coordinates of that point, that's the point 2, 7. Now if we're not sure that we're actually at the correct point, we take what we think that point is. The nature of the graph makes it kind of difficult to tell if we're at the point of intersection or not. So we test what we think is true by replacing x with 2 and y with 7 in both equations and use the original equations. So I get 9 times 2 minus 2 times 7 minus 4, which is 18 minus 14 minus 4. And we're asking, is this equal to 0? And we see that 18 minus 14 is 4, and 4 minus 4 is 0. So this does solve the first equation. Now let's make sure it solves the second, y equals 3x plus 1. So we replace y with 7 and x with 2. And we see, is this a true statement? Is 7 the same as 6 plus 1? And we see that it is. So this is indeed the correct point. So there's one solution, and it's the point 2, 7. So when you do graph this, say you're graphing it by hand, as we were doing here, you really have to make sure that you plot the points accurately and you bring the line accurately through the points. So there's our second line, y equals 3x plus 1. And now let's graph. The y-intercept was 1, and from there we move 3 units up and 1 unit right. Now let's graph the line 9x minus 2y minus 4 equals 0. So from the y-intercept, remember we found that the y-intercept there was negative 2. I move 9 units up, 2 units right, and I draw the line through those 2 resulting points. And it is a little difficult to tell which one is actually my point, so you would have to actually check to make sure